what else do we want to test in here?
Well, I would really love to optimize your desk space for body voltage if we can.
Okay. So how do we do that?
Well, we need to trace down all the electric field sources.
Okay.
So we'll be testing your body voltage
And then we got
there.
the grounding mat here as well. This is the one that's plugged into this so I've got kind of two different grounding mat setups in here. The first is this grounding mat right now is run via a cable out to the ground out there where there's like a steel rod driven into the ground. And I stand on this when I'm working. But then also, this same company, Ultimate Longevity, they sent me these which can plug into the grounding outlet here. And these will attach to like little patches that you can put on your body to ground you or earth you via those patches.
Right.
So is there any way to test whether or not something like that is helpful or harmful?
Yeah, we should test. So you normally, when you normally stand on that while you have those plugged in as well?
Sometimes I have these on, sometimes not, but we can test both.
Yeah, let's do that.
Sometimes, like an ideal scenario, I'll have just like both attached to me because I'm a more is better guy, as you know.
Yeah.
So we can try that. And the way that would look is I would basically take one of these patches like this, and oops.
EKG patch.
Yeah, it's basically an EKG patch, and I would. This one's kind of seen better days, so.
I'm just gonna unplug this for a second.
Yeah. And then we got like this Nano V here as well. A lot of biohackers are using that thing. We can always test what that's doing as well. But, some chocolate. Well, Jess is wonderful. Dark chocolate peanut butter. Or it might have been that drinking cacao I had after lunch. Anything. Chocolate.
Well, you had that coffee drink. Okay. All right, so this is on now.
River, Taryn, you guys in here? Hey guys, come on in. Come check this out. So now we're testing the grounding mat.
All right, so hold that.
Okay.
Oh yeah. Right, you had this in here.
So right now, is it plugged in or not? Because we can easily test with and without.
So this is plugged in and that's plugged in.
Okay, so right now that's plugged in. So let's do everything on, and then we can remove everything, or I'll just step off the mat. So what I'm going to do is take these two and attach these to my body, so I'm grounded on the mat and also grounded via the outlet. So I'll attach this one here.
Belly button stickers.
Yep. Attach that one there. Okay. So there we go.
So we're still at around 130 millivolts.
Okay, so my body voltage is 130 millivolts when I'm standing on the grounding mat with the grounding patches attached to me.
And then you have about 7 microamps.
So is that good or bad?
And the microamps is measuring again
Dirty ground.
dirty ground. Okay.
Mm-hmm.
And so theoretically, if I were not on this, I would see higher dirty ground.
Maybe.
Okay.
It might be lower or higher. We just need to see. So what I'm going to do is I'm going to keep those. We're just going to see what happens when I unplug this.
Okay, so first thing we did is we unplugged the 2 patches that were attached to my body. Any change?
Didn't make much of a difference. Now we're at 400 millivolts.
And what was that before?
300 and I think it was, we'll have to go back on the video. It was
Or you could just plug it in again if you want.
Yeah. So we're at 400 millivolts. Now we're at 120 millivolts.
Okay. So it was dropping the voltage potential in my body when I'm plugged into these grounding pads or patches.
Now you dropped even more from the stake outside.
So the
When I
stake outside
unplugged
is
that-
also dropping me.
Well, I unplugged the stake outside, so
And it
now
dropped.
you're at 93 millivolts.
Okay, so it appears that the patches that are attached to my body that are plugged into the grounded outlet seem to be assisting by dropping the body voltage, but standing on the grounding mat, which is attached to the stake outside, is raising the body's voltage.
That's what it appears.
So
right
of
now.
the grounding strategies that I'm using thus far, it appears that by plugging into the actual wall outlet, it seems superior than plugging into like a stake out in the ground.
That's showing how much voltage is going through your body.
Now let's see if I do nothing at all, like take these patches off, or you could just unplug that and have the grounding unplugged. Okay, so now I'm not grounded at all using any fancy grounding devices. Where am I at?
And you're at about 1,900
Okay,
millivolts.
so it definitely jumps up when
Well, it's going up and down right now.
Yeah,
180. Let's see what the microamps are. Not much change there. So here's the thing about this is we need to measure the ambient fields that are in the air and where they're going, where they're coming from, where they're going. Because when your body's grounded, just like if we ground the desk or the wall, then there's current flowing through your body to the ground continually.
Okay.
And it's going through right now it's going through the meter instead of through your body because your body's not grounded.
right.
Now let's see, if I just have you touch this, then your body's grounded.
And that drops.
And that drops all the
As
way.
we would expect if I were grounded, the body voltage would drop.
Right. And it doesn't, and then it goes back up when you're not grounded.
Okay.
So I'm going to grab one more piece of equipment in the other room,
Okay.
and we're going to show something.
So what we're determining right now, folks, is whether these grounding and earthing products that aren't the same as going outside barefoot necessarily, but that instead cause you to be standing on a grounded surface or wearing patches that supposedly ground your body, are actually dropping the body's voltage, especially in a somewhat EMF-rich environment. In this case, a room with the computer plugged in and...
Okay, so there's voltage coming to this product here.
I can flip this on and see how much more we get. So this is the Nano V I just flipped on. And this is something that's often running next to my desk during
Now
the day
you've
of
got
work.
4.8 volts.
And we don't have any of the grounding devices plugged in or turned on right now. Okay, so I'm going to run this. Okay, so now we have a device running that's generating some amount of an electrical field, which we would expect. Is that significant, Brian?
Yeah, so measure your body. 1.3 volts, 1,300 millivolts. And then it's got all this voltage coming through here.
Mm-hmm.
Now what I want to do is
To ground me and see if that
I'm
drops?
going to ground you, and I'm going to
Okay.
show something here. So
Okay.
I'm going to ground you right here to the
Okay.
electrical
And
ground.
do we want to ground me also via the mat or just that?
Just that for now.
Okay.
So now your body voltage is showing as 95. But look, this is still really high.
Uh-huh.
So where is this going? Here, take
Straight
your
in, straight into my body.
Yeah, so take your other hand and put it right in front of the antenna between the Nano V. Between the Nano V and this. See how that goes away? Now take your hand away.
Oh, wow.
So when you put your hand right in front of that, you're blocking that electric field. It's going through your body and not hitting the antenna. That's essentially what's happening when you're using this to measure your body voltage. Is
Right.
it's going through your body instead of through the meter. So it's
Right.
not registering on the meter.
Right.
And if you check the continuity between this, we can actually check the continuity of your skin with this meter too.
And so what we're determining then is that if I'm grounded in an EMF-rich environment, my body is essentially working a little bit more like an antenna.
Yeah, you are becoming part of the wiring system where the voltage is returning to the to the grid.
Now, what we need to test, however, is whether there's a difference when we are grounding by bringing this metal stake in through the ground outside versus the home's electrical system, right?
Yeah, we need to see which one's lower. So hold that side, and then hold this side on the other hand. So now I'm going to test what's called continuity or resistance of the skin. So it looks like 0.6 mega ohms. And then if I actually just test the meter itself, between, I'll just test continuity here. I need to test it the opposite way. I forgot. Oops. If I need to test the another multimeter with a multimeter. So if I test this, it's 12 mega ohms. So the skin's resistance is less resistance than the meters themselves. Right. And so that means that if there's a lower voltage on your body, the voltage is going to travel through your body instead of through the meter, so it won't register on the meter.
Right. That makes sense. So that meter isn't going to help us to measure that significantly what's going on here with the grounding mat. Then.
Yeah, we can measure the difference in voltage between the grounding mat directly and the...
Okay, so now let's unplug the patches, then plug the grounding mat in and see if it's still producing an issue. But essentially what it looks like is if I'm using the home's grounding outlet and running something that's producing a lot of EMF in the same environment, my body is going to be acting as a little bit of an antenna. And now we're going to find out whether if I'm grounded using the ground outside instead, if my body is still being used in that way, or whether that's a safer way to ground.
And then we also want to measure the beneficial frequency. So which one are you getting more DC current from? All right. So what I'm going to do is I'm testing the ground that's outside with the house ground, and the difference here, it's about 360 millivolts difference between outside versus inside. Microamps is a lower reading, 3.8. $380 millivolts difference between the two. And then we'll test the DC current. Actually, we'll test the DC voltage first. 855, 860 millivolts. That's the microamps. So I got 8.0 microamps DC, which is great.
Okay.
And it should be the same the other direction, actually. We'll just keep that plugged in, and you're definitely getting more grounding.
So what he's testing, River and Taryn, is the amount of grounding current that is produced by the outlet in the wall versus the amount of grounding current that is delivered from a stake planted out in the ground. And the amount delivered from the wall, you're saying, is more, Brian.
More, yeah. Yep. And you're also getting transfer of AC current. So this is why when we recommend to do the shielding and the grounding, that everything has to be grounded at the same location. If you have two different ground potentials that are like 300, even 100 millivolts difference, there's going to be an influx of energy from
Right.
one place to
So
another.
theoretically, I should not be standing on a grounding mat, grounded outside, and at the same time be grounded via like a patch that's grounded inside.
Right.
I should have one grounding source, and as I think we still need to test, that grounding source should not be turning my body into an antenna.
Right.
And it turns out that if I'm grounded using the house grounding, even though it's dropping my body's voltage potential, it's also exposing me to a higher amount of EMF produced by any of these EMF emitting devices in my office.
Yeah.
And so the next step then would be to say, okay, is grounding via the outside stake that is staked into the ground going to also produce that same effect? And so what we would
Right.
do then is we would plug this one back in and unplug that one, which is already unplugged.
Yeah, we'll plug it into...
And then test me with this Nano V running, but with this guy, with that white cable plugged into the grounding mat, and find
Yep.
out if this is a safer way to ground than being grounded into the actual outlet of
Here's
the
what
wall.
I'm going to do. I'm going to take this. I'm going to use this because now that's connected to you, and this is the ground. So I'm going to ground.
And I can remove these patches if I need to.
Yeah, leave the patches on because you're
Okay.
going to be my ground source. All right, I'll take this out. Calm there. All right, so now I'm connecting to this ground to test that. And this is connected to Ben's body, which is touching the grounding mat. And now got just a tiny bit of DC current. .45 millivolts. .120 to 150 hertz. That's just like static electricity.
Okay.
Okay. So to me, it looks like the outside is a lower voltage potential.
Right. So if I were going to have my body grounded, especially if I'm running devices in here, it's better to be grounded via stake that is staked into the outside ground versus being grounded into the wall.
Right, but we need to block all the electric fields from hitting your body. That's the first step, and then
And how would we be doing that?
well, we need to first, the walls being shielded is a first step, but then all the devices need to have a shielded and grounded power strip here. All the cords would need to be either replaced or put behind something that's grounded so that the electric field's not coming toward you.
Yep.
That way, it's acting like what your hand was acting like when your hand was grounded. You acted as a shield,
Yep.
and it blocked the electric field from coming onto the antenna. So
Right.
if your body's an antenna, we need to block the whole
Okay.
antenna from receiving
makes
any
sense.
electricity.
So if people are listening in and they want to outfit their offices in this way, what we'll do is we'll just generate a full report. And as long as we leave my address off and everything, I don't mind putting this in the show notes for people.
Yeah.
So again, it's going to be bengreenfieldfitness.com/shielded healing podcast. And Brian will just show his full setup that he recommends as far as the cables, any grounding equipment, and anything else in the office for mitigating the EMF in here. In which case, once you've taken care of all of that, if you were going to use one of these grounding mats, you'd want it, if you're able to, and you're on a ground floor office, have it just run straight through a window or a door and metal staked into the ground.
Yeah, and it's really important to know that you kind of need to have this stuff tested so you know that you're setting it up right. You don't want to spend a bunch of money doing a big
Especially
shielding project.
if you're grounding something outside of your office and you're in the middle of a bunch of office buildings and there's a bunch of power running. We're out in the middle of the forest. So
Yeah.
Okay. What else in the office do you think that we hadn't tested and shown in the last video? Because I know we tested the Juve lights and we were looking at flicker on those, tested the overhead lighting. Anything else in here? I know we're going to test the Morozco Forge, the ice tub out there.
Yeah.
But as far as the office goes, for the actual video and audio part of this podcast, is there anything you think we should test that we didn't show in the other episode for folks?
Yeah, we should. So this should be.
Wow.
All this stuff can be grounded. So these cables here, anything that has a grounded detachable cord, we have shielded versions of that on the website that we
Amazing.
can link, and you can just replace that.
Sweet.
the shielded version. Looks like Juve gave you shielded cords if these are plugged in, so
Yep.
that's good. But basically it's the same as what these are, you know.
Yeah.
These just plug
Yeah.
in like right there to that
Yep.
type of attachment, and then that's grounded. So your monitor has one. We should check your monitor for flicker. And then,
Yeah, this is the ISO Flex Scan monitor with the Iris software installed, so I would expect flicker to be somewhat minimal compared to a standard monitor without screen protection software installed.
right.
We can
So
flip it on there and see.
Yeah, let's see where my flicker meters are here. Okay.
Okay, are you able to test, total random question while you're doing that, not to distract you too much, but are you able to test blood glucose monitors? Or have you before?
I haven't before. That'd be
I'm
interesting.
wearing
though.
one. It'd be interesting.
Yeah,
Test one arm versus the other arm.
Let's turn the lights off for a minute,
Okay.
if that's okay.
Yep. Ready? Here we go. Lights off. You want to flip that one off back there, brother?
I think that's the screen.
So we're testing the flicker on the screen now and make sure that Iris is running, which it is. Iris is running in health mode. Here's what it looks like in sleep mode. No difference.
Flickering at 200 hertz.
Is that significant?
Yeah.
Now, what if we press mode here? Okay, so that seemed to change it. Oops, sorry.
Yeah, now it's not.
Well, yeah, that's because I changed the display, but what I meant to do here, so, was go,
Why does it
go to here. Here we go.
It seemed fine for a minute, and then
Well, it's because I totally disconnected the actual input, so I wasn't taking the input for a second there. That's paper, movie, user. That doesn't seem to make a difference.
see this one. There's your Apple screen.
Apple screen.
There's this new monitor.
Why is this one so much less?
So what I found with the Iris is the Iris does a good job if the screen is healthy itself, if the screen is modulated properly, does a good job with the blue light and can adjust some other settings and everything, but you're kind of limited by the hardware of
And this
the
hardware, I
screen
mean, this is
itself.
the ISO Flex Scan monitor that is supposedly lower flicker and is a more retina-friendly monitor. But it's producing more than the native MacBook monitor would appear.
Well, wait,
Yeah. So the monitors
Yeah,
that
we
I've
tried that.
the monitors that I've been using and recommending are the ones that have eye care technology.
Yeah.
And so there's some by Asus and Acer. They're the kind of gaming monitors.
Can you include those on the report?
Yeah.
Because I'll make sure that that's in there for people to see. Because
Yeah.
I'll totally replace this if you know that those produce less flicker. Because
Yeah.
obviously this is producing something, right?
Yeah, a lot. I mean,
Yeah.
it's nothing
Which
there.
I'm staring at this screen like at least 4 or 5 hours a day
Yeah.
working.
Now, if we flip back on the lights, here's the interesting thing.
I'll flip those on.
Usually that will help reduce somewhat, but we're not there.
So you're getting less with the lights on?
Yeah.
Huh.
So
So with the lights on in the office, I'm getting less flicker
Yeah. So
from the monitor.
So the incandescent bulbs, they're filling in the gaps of the flicker, and that causes there to be.
Now go ahead and flip those lights on again. Let's try my red light now. This is how I work at night.
Yeah.
Yeah.
So you should get one of the lights that your boys have. They're gonna get upstairs.
All right, so we're gonna be changing up some stuff in the office for sure. Might be outfitting with the new monitor. Wow, learning all sorts of good stuff. All right, cool.
So,
Wow. Lots of stuff to change up in here, fellas.
yep. And
No
then we just need to
surprise
get the
there, though.
cords under control.
Yeah.
So you got
Yeah.
some grounding stuff. Some things grounded here. I see that's good.
Yeah.
But we just need to
Yeah.
figure out
Well, if
which
you-
ones are live cords, and
Yeah.
then those ones, if they could be replaced, we replace them. If not, then we need
Yeah.
to kind of
And
stuff
if you got to
them.
pop in here later on too, that's fine. If you need to go through and test everything.
Yeah.
All right. So the other things I wanted to show while we've got the video is the let's see. Oh, we wanted to do the Morosco forge. That was the main one. The Morosco forge. So let's go out and test that one.
All right. So that we're going to test grounding and let's see.
Woo! Icy ice. Look at that. That is, so there should be a temperature probe in there if you pull up that black cable. That temperature probe, the reason the ice froze is someone took that out of the Morosco. You put it through that metal thing, right? So it sinks down to the bottom because you want that metal probe as close down to the bottom as possible. There you go. And then you just, once it's through, then drop the whole thing in there. So that thing sinks. There you go. And what we want to test ideally with this unit is we want to make sure that all of this control, you know, let's say somebody's sitting in the ice tub and they're doing like a 10-minute ice bath and their head is like resting right here. You know, what are they getting exposed to? That's the question.
So that motor is on usually when you're in there?
So the motor will turn on occasion when it needs to fluctuate the temperature. So what we'll do is maybe just to start that occurring. Oops. Okay. Okay, so this thing's running now.
All right.
And all I'm curious about is if we're getting much EMF produced from this.
Doesn't look like there's much magnetic field. Here, we should see if we need to ground the tub or if the tub's already grounded. We need to verify that.
Okay.
So that's what we'll do here. Plug into
Hey,
this
NASA, you up there? Do you know if he ever figured out that outlet, if he fixed that outlet on the side wall for the Morosco? That guy? Remember when Adam's brother was looking at the electricity?
Yeah, he's coming later.
Oh, okay. So he's still working on that one. Cool.
Okay. All right, which one of you boys wants to hop in the tub?
Nobody wants a little post-lunch soak?
No, we'll just check it on the...
Yeah, for some reason right now an ice bath doesn't sound appealing.
All right. So current, let's start with that since I'm already on the setting.
Hey, River and Taryn, come check this out, guys. Remember, this is a learning day for you guys, okay? So watch what he's doing here.
So I'm checking the water itself for current. And there is there's some electrical current in the water. Let's see the voltage. So this is grounded. 0 voltage on the tank and in the water.
Well, that's good.
Current, I'm wondering where that's coming from. So if I'm probably from the house ground to
Yeah,
the
right
body
now I
up
have
here.
it plugged into the office, although normally we actually had an outlet fail out here. Normally I'd have it plugged in out here, but I'm just running the extension cable into the office.
Okay.
power this thing. But it should, I don't think that would make much of a difference.
No, it shouldn't make too much of a difference. So 120 toward the house.
Basically, the water's pretty good.
Yeah, let's see how much DC current you guys are getting. So I'm getting DC just standing here barefoot, 7.8 microamps. DC current standing barefoot. If I lift one leg up, like a flamingo, I'm at like 5.
But the DC current that you're getting, is that just from the normal ground?
Yeah, that's from the ground. That's the beneficial.
That's
what
just
you want.
grounding or earthing, right? What you
Look at that.
When you're in the water, that's huge. That's super significant.
Yeah,
So that water is somehow charged.
it's really good grounding.
Have you seen that before? I mean, is that a good thing that it's grounded like that?
Yeah,
Okay.
that's very, very good.
So that means that you're not getting exposed to dirty electricity when you're bathing in a cold tub because the tub's properly grounded.
Yeah. So
That's good.
you going in there, that's like more of grounding therapy than grounding all day.
That's awesome, guys. That's
Like-
good to know, huh? Because River and Tara and I are in here almost every day.
Yeah.
Every day, but
I've been in here every day for the past 2 weeks. So, I mean, only for like 3 minutes because it's kind of cold.
Yeah.
Yeah.
So as long as this is properly grounded and you're surrounded in that grounding material and you're wet and your body is conductive, you're going to be getting really, really
Two
good.
thumbs up. So what we do is you do the biocharger and then you just go like re-ground yourself after the biocharger in the ice tub. There's your 1-2 combo. Charge yourself up and then restore your normal electrical current. Cool. Well, that's good.
Yeah.
A little
that was
peace
really
of
cool.
mind.
All right.
All right.
While we're out here, we can just check on the ground itself. And I'll do the AC and the DC. So from the house ground to the ground outside, I've got like 9 microamps of DC, but I got 34 microamps of AC. So this microamp reading, Sam Milham, the author of the Dirty Electricity book, one of the world experts and epidemiologist on dirty electricity and all things EMF, he says that there's a government study that shows 18 microamps as being carcinogenic of this contact current for alternating current.
Now, where would an alternating current be coming standing out here in the forests out in the middle of the grass?
That's ground current that we're getting
From the wiring in the home?
from the wiring in the home or coming
surrounding homes.
from like the electrical distribution.
Got it. And is that something that can be mitigated?
Only if you have a completely conductive surface in an area where you're not acting as a conduit. Right now, I'm getting some kind of field from somewhere, and my body's a conduit for the ground.
Wow.
So I need to be shielded from.
When you say a field
that
from
field.
somewhere, would that be from a tower?
It
Or
could
from
be
something in the ground?
It could be from the ground going through my body to the house, or the house this way.
That way and a tower that way.
Yeah, this would be more like dirty energy going on the ground.
Huh.
Well, also remember, Dad, they
Makes
took
me wonder about what would be out here in the middle of nowhere.
out that tower that was doing the internet thing that was right by
Yeah.
the trees and everything.
But this would be something traveling through the ground, not through the air that he's measuring.
Maybe the water in the aquifer.
Well, it could be that. It could be one of those geothermal spots that he was talking about.
Yeah, there's potential for that. So one of the things, with the geopathic stress or the telluric currents, is that because there's conductivity in the Earth's surface, we also have all these man-made frequencies that are penetrating into the Earth and conducting onto those natural conductive surfaces on the Earth's crust. And so those are resonating and vibrating and sending out frequencies themselves because of how much we've saturated the Earth with these frequencies. So let's see.
Interesting. So guys, we're even getting frequencies just from the Earth being like an electrical grid right out here in the forest. Although some of it could be these natural geopathic stressors too. You testing that grounding stake?
Yeah, I want to test from there to my body.
Okay, well, he's testing this. I'm going to mute myself because I have to go take another leak. We don't want the sound of the waterfall on the mic, so I'll be right back.
Yeah, we should have mystery waterfall water. Yeah, we should have. So peaceful. I want water freeze or something.
So I'm just getting a few spikes of the alternating current out here. When I ground to the stake in the ground outside, I'm not bringing in any current through the meter itself. So grounding out here is definitely more healthy than grounding near the house.
So the farther you go, the more healthier it gets. It's like the perfect grounding chair. You just sit on a rock that's shaped like a chair.
That's great. Here, let's test you over there. Here, so just go ahead and hold the end of that. So 3.5 microamps DC. There's no AC on your body. The AC is the man-made. The DC is what comes from the earth, God-made.
Yeah, that's good. No AC is 1 ohm, DC.
All right, and voltage is 0, and DC voltage is 270 millivolts, which is good.
We did recently have a bit of thunder last night, so yeah, we did have a storm before my dad's house.
Yeah, it was storming pretty hard.
There was some lightning, so yeah, lightning.
You know, when there's a thick clouds like that with a thunderstorm, it makes it so the satellites don't work as well. So like when I was driving here last night, my GPS wouldn't lock into where my car was driving to. So normally I load the GPS beforehand and go, but it wasn't loading because the clouds were so thick it was blocking the satellite signal for the GPS, which is about 9.1 to 9.4 gigahertz. So normally we're just pretty much bombarded with those frequencies all the time.
Now, as far as satellite frequencies, when we're in our home, would some of these shielding technologies like the paint and the curtains and stuff be helpful when we're inside our house?
Yeah, definitely.
We just need like giant sun hats when we're outdoors now.
Yeah, big umbrellas.
Yeah.
Something.
Scary.